So we are ready to start. Welcome everyone to the October edition of the Software Developer Thursday. The last time you saw him as a Jedi, today it's in
I have to lower the
incognito.
expectation.
So today there will be Eduardo Guerra presenting us how to develop with annotation and his experience of 20 years or more than 20 years of Java developers with annotation. I'm curious to hear your presentation and don't steal you much more time, so thank you, Eduardo, for coming, and the floor is yours.
Thank you very much. Okay, already passed a lot of stuff here. Okay, so to present myself, I'm a Brazilian and Italian. Of course, if there's a soccer match, I will cheer for Brazil. I'm a nerd, as you can see. Researcher, judoka, I'm a brown belt. Agilist, board game designer, YouTuber, software architect, neurodivergent, educator, podcaster, cosplayer, Java dinosaur. As you will notice by my presentation, I reached the point where my students were born after I start programming in Java. So then that's and a pattern author. Okay, so I will start with a bit of history. So that's the part that I kind of, you will notice that I'm a really Java dinosaur. So it first started with the when people realized that some properties like security and transaction management could be declarative. So we didn't need to, for example, open a transaction and close and have all of these. We could say, okay, in this method, we want the transaction to be handled like this, have something behind that does this for you, or say like these components can only be accessed by this kind of role, so we don't have actually to program. And then we had the AGB2 deployment descriptors. So this was really ugly. That's why we have our friend there. It was like huge XML files. If you have a system with a reasonable number of components. So this amount of information, it's not even one component, right? So every I don't know, business component you had a lot of stuff to put in. You needed to create like this remote interface, this home, the local interface, the actual class. So it was very, very bureaucratic to do all of this. Like without a proper IDE was almost impossible. It's a lot of work, much more work than actually programming all this stuff. And then someone has a nice idea, which was the xDoclet, right? So what was this? Java has a tool that is to generate documentation, right? The Java doc, right? So you put things like this, and then they figure out that you could create extensions for this tool that generated this documentation. And then they figure out, okay, maybe we don't need to generate only the documentation. We can put some things like this here, which is kind of the information we need to generate this XML file and even generate all these interfaces that we need. And then, okay, it's easier to manage because we don't have like this huge configuration file. We can put the stuff right here on the class itself, right? So then that became kind of the standard way of developing these kind of applications by using this kind of tool that they call like attribute-oriented programming by putting this, as you can see, like this is inside a comment, right? So then they put this information. There was this tool that generated the files for us. still not very nice, but was what we have at this time. And then they figure out, okay, if now we are doing the applications like this, let's make it official. So why not put this as part of the language? And then we have on 2005, and yes, I remember that time, so then you can see. I was like, hey, now we have this kind of thing. Was this JSR, which was how things were added in the language by the time, was this a metadata facility for Java programming language, which was what introduced in Java the code annotations, right? So if you don't know what I'm talking about this kind of stuff here, right? So if you are, for example, developing in Spring, you can, or a web, I don't know exactly which framework is this, but you can put some information. If you are mapping classes to the database, you can also use annotations. There is like JUnit, you can use annotation for marking the methods with tests. So there are many, many cases in which you use the annotations, right? So then, three characteristics that is very important. It's like, first of all, it's close to the code, so then it's not a configuration file that I need to go, open another file, search for the information about my class and put it there. Okay, if I need to put an information about the class, I put right there, so that's a benefit. It requires compile time changes, so in a sense like it's inside the code. So if I need to change a configuration and annotation, I need to recompile that code to redeploy. It's different from, for example, this idea of the deployment descriptor, which is, okay, it was an ugly file, but theoretically I could change it at deploy time, so I didn't need to recompile. So this is a bit of a drawback. And an important fact is that the annotations has no behavior associated. So putting an annotation in a code does nothing, basically, just add information. It is someone else that needs to go there and read, right? So which makes the annotations kind of make a low coupling, which is like, okay, I'm just adding information here. I'm not really connecting my class with some kind of behavior, right? So today, for example, I just pick up the new APIs from Java from AI agents. One that is getting a lot of attention is LangChain4j. There is now like Spring AI as well. And both of them use very heavily annotation. So it's not like, okay, it's from 20 years ago, now nobody uses it anymore. All the new APIs done in Java, they have these annotations in mind and use it for making things easier, right? So it's not something that is outdated. Okay, so me, when I see code annotations at 2005, I was like, oh, this is really cool. By that time, I was kind of really into software design and reflection and stuff. So these code annotations was really, really a cool new addition to the language. And I quickly get interested in, okay, we have a new thing, and that changes how we design software, how we design frameworks. And then I decided by the time that I wanted to do a PhD to focus on this. So from the moment that was released, I was start studying it. I developed many frameworks, did many studies, wrote many patterns, like studying the existing software, identifying the stuff. So I'm really into the annotation. So for these 20 years, so that's why the name of this talk, what I learned in 20 years, not just by using, but also experimenting and doing studies in software repositories with practitioners. So what I'm going to share here today, it's a bit of what I learned on this, right? So I also have this Sphinge framework, which is an open source framework. It's kind of an umbrella project, have frameworks based on annotations for things like gamification, polyglot persistence. The last one on the family is about green, which is the green Sphinge. And I was really happy to do this connection. And about continuous experimentation. So there are many frameworks where we use the annotations to do stuff. So I also did some practical things. I have a book in Portuguese, unfortunately, about reflection and annotations. And the coolest thing is that many people see and think it's a self-healing book because it looks peaceful and annotations, reflection, etc. But when they open, that's kind of hard stuff there. Okay, so then what I did was I pick up top 10 facts that you need to know about code annotation, right? So I will go through these 10 facts and how do I find out about them in these years. So the first fact is that annotations are used by a lot by Java programmers. It's not like a programming feature that is used by few. What we did, so we have this study where we have some metrics for annotation. So we pick up 25 open source projects that we selected from GitHub, and we analyze almost 25,000 annotated classes, right? So what we find out in this study, for example, 76% of the classes have at least one annotation, right? So then you can see that most of the classes have at least something. The median number of annotations per project, it's higher than 1,000. So it's not something that you can ignore. And 10% of the classes use more than 11 annotations. So kind of a significant part of the projects had thinking about each annotation, it's kind of one configuration in the class, has a reasonable amount of stuff being defined through annotations. So it's not a feature that we can ignore. The second fact is the abuses with annotations are worse than you think. And then it was in the same study where we start to see what were the crazy stuff. That's the fun part, right? When we find the weird stuff. So just some examples. We have one class with more than 700 annotations. Can you imagine how ugly it is? We have one annotation, just one, that have 26 lines of code. So can you imagine one single annotation so big? And we have one element, like I think it was a class that have 41 annotations. Okay, these were like the worst cases. Which mean like, okay, maybe we can get some with more than 15 lines of code, right? So then there was some also weird, not so bad, but yeah, so there are some ugly stuff that was not the worst, but just pick up the worst, just for you to have an idea that things can get out of control. Right? So then if you are thinking about the problem was large methods, big classes, and I don't know, large number of parameters, welcome to a new problem, which is a large number of annotations. So abuses happen. Okay, so now a more peaceful one. Annotations are applicable in several scenarios, right? So one of the things that I figured out is that sometimes the developers, they have some experience with using annotations for a particular thing, and he cannot see what kind of other things he can do with that, right? So I pick up, we have like, we were able to identify like 5 different scenarios for the last one, I have an observation. So the first one is information mapping, is when you use the annotations to map a class to something else. So you can map methods to a service, like an endpoint. You can map a class to XML. So it's the code without annotations and with annotations. You can, for instance, map a class to the database or to JSON. So this mapping, it's a very popular case of annotations. We have dependency injection, which is also really useful. Instead of creating something, you can mark it with an annotation for someone else read that annotation and put that instance there to you. Callback methods, you can put some annotations on a method that can identify when that method needs to be called, right? So then you can mark, for example, for event listeners, and it's very useful. And a cool thing about annotations is that you can, for example, have attributes that define more in a more granular way when that method can be called, which is something that is not possible with interfaces, right? So then it's another use. We have the proxy configuration. So when you have something that goes around your class, so like a proxy or a decorator, you can use these the annotations to configure, like for what we call the cross-cutting stuff, like security, logging, and other things. For example, in the case that I said, like gamification, like, okay, this is wrong. But that's not this point, comma here. But so the idea is to, for example, instead of doing like a security inside the method, you just declare, and someone else that will invoke will filter this to you, right? And the last one, it's the rule definition. So when you have some rules associated to this class, like, for example, okay, it needs to be persistence, or what we used to do is like, we put some static final stuff to mark the class. We can instead use some annotations as a way to configure stuff on the class. And this one is like the category we have that is more general. So it's a bit like, okay, you are configuring how some other component needs to deal with your class. So it's a way to pass parameters with the class. So this one, let's say it's the category that is more general. So how do I know that these are the categories for annotation use? So we also did some study. We pick up 30 projects. We use standard Java API, so we pick up 21. We also pick up 21 third-party APIs from these 30 projects. We have more. And we analyze that amount of annotations. And then we were able to fit them in all these 5 categories. And we didn't find one annotation that we couldn't classify. And we have just a few cases that it was classified by 2 people, and there are a few cases that was some disagreement, initial disagreement. Then, okay, we based on this, we we were able to figure out these 5 possible uses of annotation. Okay, so I know all of you have your opinions, and I want to know your opinion about annotations and code readability. So who here thinks it improves code readability? Who think it gets worse? You? Anyone else? And the others don't think anything. Okay. Who is right? None of you. Doesn't affect. Okay, this was really a surprise for me because I thought it improved, and I thought it will improve at least in some specific cases, right? So we have a survey. So we have this paper. It's 2024, so not so far ago. So we asked people to classify. So we give two codes, like the two codes that I show you here, like very similar size. What just changes using a classic or object-oriented approach and an approach with annotation. So we ask people to choose which one they found more readable, without annotation and with annotation. An interesting thing is like, okay, which one is more readable, for or while, right? So then, I don't know, it's the same. But when you are creating the code, you need to choose one, right? So we didn't have like a neutral option. There was like, okay, for me it's the same, but I will choose this one. So then we didn't have like a neutral because, okay, if you are doing a code, you need to choose, even if for you it's the same, right? So then this was the distribution that we have, a normal distribution. And we get a normal distribution for all the questions. And the thing is that it was not like everyone voted kind of the same. It was like, okay, people voted here. This one I prefer, this one I don't like, blah, blah, blah. We did that based on these categories to make sure that we cover all type of annotation uses. And even though it was neutral, we try, okay, let's see more experienced developers, beginners, all normal distribution. So we couldn't really say that, okay, annotation is good for readability or is bad for readability. It's kind of a matter of preference. However, we have haters and lovers. We find out there are some people that really don't like it and some people that really love it. Maybe it's my case. But, and then maybe you are one of the haters or some of you are one of the lovers. But the fact is that if you consider the average case, doesn't matter. So basically our result is like, if you are going to choose using annotations or not because of code readability, don't. Consider other factors, but readability is not an issue. Of course, we have the extreme cases where you can have, okay, 15 annotations in one element will have a bad readability. But then it's about maybe a bad API design or bad design choice. It's not about the annotation by itself. It's like, okay, any programming practice, we can make it ugly, right? We can screw up, but it's not the annotation itself who is guilty for this. Okay, another fact is the fact that errors in annotation are really hard to debug, right? And the thing is, the annotations, the errors are kind of hidden, right? It's a bit like if you put an annotation on a wrong element. Maybe you need to put on the getters, you put on the setter. Maybe you run, it just don't work. Or like, but I put the annotation. What I'm doing wrong? So it's kind of hidden there. Another thing that I already see is like you misspelled the name of an attribute. So, for example, you are supposed, for example, to put in your annotation the name of a method, and then you made a mistake by one letter, and maybe you just don't find the method and don't give an error. So you just don't call the method when you are supposed to, and then you're like, what I'm doing wrong? And sometimes it's kind of a lot of time before you notice that this happened. And one of the issues is that the debug don't pass through the annotation because the annotation don't have behavior. It's just a piece of information that someone will look for it. And if the information is not there, you just don't find it. And it's not really an error. It's like it is not there if it's misconfigured. So then this was an issue. And in the programming experiments. I did a lot of many frameworks, many solutions we did. Sometimes the participants were like, okay, why is not working? Why this is wrong? And sometimes they have a really took them a lot of time to find out this. It's different from an imperative error on the code that you can debug and say, okay, here is wrong, right? It's just don't work and you don't know why. And then validating annotation is very important, right? Okay, if your annotation should be on a getter, you should go through all the class, maybe if your framework or your API, search if the stuff it's in the wrong thing, it's in the wrong place, and validate this. If you are, for example, if an attribute should be a method name, search and see if it's a method name, right? Some even famous frameworks and APIs, they don't have a nice validation of the annotations. For not like, okay, you are, I don't know, Java is strong type, so okay, this is the type of the attribute is integer, you are putting a string, not this kind of error. It's the kind of, okay, you are supposed to configure this with this kind of thing, you put the right type, but you don't have a link. So this kind of thing is hard to find, and okay, there are solutions we can use for that. Okay, now a good thing. It's more bad things than good things, but we do have good things. The fact 6 is that frameworks with annotations make the code more consistent. What that means? That means that, for example, if we have, okay, let me tell the story. So we did an experiment with 10 participants. Half of them use object-oriented API, and half of them use an annotation API. They developed the same functionality, right? But it was not like one task. It was 10 tasks. So they have to do 10 things, one after the other. Every task has a suite of tests that they need to pass. And each test has a test, and then it was based on real-world functionality. And we have things like this. So Sphinge metadata is the API. Normal Java reflection was the other one. And you see that the ones that use the annotation-based API, they kind of flow the same, right? So this is complexity. And then you can see that some of the developers, they were not bad. But some other two really diverged. And here with the coupling, so you can see that the solutions with metadata is kind of the same, and the other ones are very different. So what we can learn from this, like it's more predictable. So the way of development is more the same, right? So then usually when we do the experiments, like the results with people that use the solution with annotations has less variations than the one that did not. So then, okay, maybe if you get a really good developer, his solution might be even better than the one with the annotations. But if you have a lot of developers, if you want to guarantee that their result will be kind of the same, and you want them to follow the same standard, then a solution with annotations will help with this, right? And this is one example, but we find this also in others. So then the idea is that they guided the development on a more stable approach in terms of coupling and complexity. And this we also find out in other experiments we did with annotations. So it's a bit like you get your developers more under control. So if you get some junior ones that can mess up, then okay, the annotations, it's your thing to save. But maybe if you get a very senior one, he could do a better work without it, right? Or even get something similar. Another fact. Now the bad. Let's go to the bad ones. Annotation are repeated a lot inside the same project. So the fact that you need to do a configuration and sometimes you need to configure many classes in the same way, that creates a repetition of annotations inside your project. We did a study with this. Does it make sense to have application-specific code conventions as a complementary approach to code annotations? And then we find annotations repeated kind of 10 times in code elements with shared characteristics. So we could have, like, for example, 17 conventions, like simple rules, that could replace around 900 annotations. Kind of 21% of the annotations could be eliminated by 17 simple rules. Just to give you an example, for example, some things like like at ID on fields where the name is ID, or message driven in classes with the interface message listeners, at get in methods with the return type response. So things like this could become some, and then you can see like the number of classes that repeat this, they are not small. So then if you could define some rule, you could eliminate all of this annotation repetition. Redundancy and misplacement are sources of bugs with annotations. What is this? We have this study. This one is not mine, it's the only one. Characterizing use evolution impact in code annotations in practice. So what he did was he evaluated many projects on GitHub, and he find out, for example, what kind of thing create changes in lines of code with annotations. And he find out that 15% when you have an annotation deleted is because of redundancy. So you basically already have this configuration somewhere else, then this annotation was not needed there. Or maybe you have a convention or something like this that make this annotation redundant. And kind of 25% of the annotations deleted because of misplacement. So meaning that, okay, this annotation was moved for somewhere else because it was in the wrong place. And that is exactly the stuff that is hard to debug. So you can see that it happens a lot, and it's hard. So then these are some of the kind of bugs that happens because of annotations. The fact 9 is something that when I start working with that, I imagine like, okay, everyone is now adopting this annotation-based framework. So probably the developers need to are more productive by using these frameworks. And this is not what I found. So I never conducted any experiment that compared a solution with annotations and a solution without annotations that I found an improvement in productivity on the annotation side, right? So the first thing is that development time is a complicated metric because small things can interfere. And first of all, if you are using a new framework, that's always a learning curve, since it's not like, in the other case, maybe it's just code, so you know it's programming logic, that if you are using a framework, you need to know what to configure, how to configure. That's always a learning curve, especially if it uses a different approach, like the annotation configuration, which is more declarative. It's new for some people. Not everyone is used to that. And then, okay, that's always something that you need to figure out. And then the small bugs like this misplacements and misconfigurations can take a lot of time to find, so that can make some task that would take, I don't know, 10 minutes in something that will take almost 1 hour when this person finally found the error. And then in the experiment, one of the results we get is a balance. So it's a bit like, okay, maybe that's no big difference between in productivity, in development time, in using annotations or not. But in the cases where we get a difference, not a large one, but in some cases we get the without annotations were usually the fast. But considering these things. But basically, like, looking at this, even if, okay, but what if we eliminate this curve? Do you think they will be more productive? I think, like, if they are more productive, probably not a lot, right? So maybe some people can get more productive, but I don't think it will be something generalized. Otherwise, will appear here somehow, right? However, going to the last fact, but a good one to finish, because we get a lot of another one, is that that's a strong evidence that code with annotations are more maintainable. So that's one benefit that we always find. That is the fact, okay, maybe you will not develop fast, but then the code with annotations, it's easy to change. It's easy to evolve, right? And when we get questionnaires, so I just pick up here some example of a study where we compare these two approaches. And this is something when we do some interview, when we have a survey where the participants can give their opinion, we always find this is a recurrent result that they judge with the annotation the code is more maintainable. And this is kind of confirmed by the metrics because we usually have a lower complexity and a higher decoupling in the solutions with the annotations. Why that? Because the annotation is kind of separate from the method body. So when you need to implement this as a logic, sometimes you can mix stuff in the middle of the method body, then you have maybe some conditionals and other stuff. You need to invoke something else, so you get the decoupling, while the annotation, it's kind of out of the method and a bit apart. What about the future? So what we can do about it? So we are working on some stuff. One of the things is that we need a better API for annotation. So also now looking from the point of view of who develop applications that or develop APIs based on annotations, the API for creating this kind of stuff is really simple. It's really like, give me the annotation on this thing, right? So in some case, like for example, these annotation validations and many things that are useful for many solutions, we don't have a good API, especially the standard one about this. So this is something that can improve a lot. And then, of course, if you have an API that make easy to do stuff, people will do these best practices more frequently. So then the chance for them to improve this kind of thing will increase. And another thing that we are now investigating is the possibility to combine convention over configuration from with the annotations to reduce the repetition. And especially on these abuse cases, we saw that in many cases was because of this repetition. Sometimes the applications, they don't have a choice because the frameworks kind of impose the way they need to use the annotation, so they don't sometimes have a choice on how to use this differently. And we are working on the possibility to define conventions. Of course, if you are not a very fan of conventions, we are also looking at what the problems they have. For example, okay, I have a convention that a method that have a certain name, it's kind of having this configuration. So like using a name convention, replace an annotation. on the other hand, who looks at this class don't know that there is this configuration there. So one of the things we are doing is like use code augmentation, which is something that I'm doing with Andrea there, and use the code augmentation, for example, to show the annotation there, even if it's not, right? So, okay, it's a code convention that, because of this means that there is an annotation there, but then you can see as if it was there, right? So then you can have these conventions and you can see them in the code. So then this better support for code conventions, something that can also help in some of the issues that we have with the annotations. And that's it. Thank you.
Thank you, Eduardo. Really interesting presentation. So now it's your time. So someone has a question or a comment that would like to share with the group?
You said You said that annotation don't change behavior, but for example, the thing that triggers the method if the event has 2 clicks and some other condition, who executes the method then?
I like to say that, for example, the annotation is like when you put in a door something like only authorized personnel allowed, right? Because that sign don't prevent anyone from entering there. The people can still open the door and enter the same way. But the person who is going there that needs to read the sign, oh, I'm not allowed here, and that person makes the decision. It's different from put something that really locks the door. So it's a bit like this. The annotation is just the sign, doesn't do anything. It's who is dealing with that class that needs to see that the annotation is there, like the person looking at the sign, right? And then do something about it.
Okay, so for example, if you have the rule that says like only admin privileges can do this, like this doesn't prevent other classes from using that or someone else, but it says...
Yeah, you need to have a framework that will wrap this class with something that will read this annotation, then this other one will prevent.
Oh, okay.
It's like, then you put a security guy that will read that, it will not allow people to go in there. But the sign itself doesn't do anything.
Okay, thank you.
Okay. It's like, for example, completely random comment. If you sometimes I'm driving and I just see some signs like respect the signs, and I was like, if someone already don't respect the sign, why he will respect this one, right? So then it's like if someone is not reading the annotations, if you put an annotation, read the annotation, so will not make sense. So okay, just random comment.
Yeah, thanks for your talk. I'm also kind of a almost dinosaur in the Java area. So I like the surveys you did you make a survey that kind of asks people about debuggability of the resulting runtime? Like, for example, I would say there are good and bad frameworks that use annotations. And like, if you know Mapstruct, that just generates code, you can debug it. If you use Spring, it's impossible to debug anything. You have like 100 Java proxies in between your code, and whatever happens. Did you do any?
But for example, then the point is like having. First of all, the point is like, for example, for Spring, right? It's to have the validation of the annotations, right? Because okay. In Spring, to have some annotation on the method only makes sense if your class has this annotation. And then if you don't validate that, then you can put only on the method and get frustrated. So when the framework provides some a mechanism that can, okay, when it runs, he said, okay, that's an annotation misplaced here, then it helps a lot. But it's a bit like it depends. The problem is that it depends on the framework. So the API or the framework needs to do this work for you, and many of them. And I think it's a bit because the API it's really simple, right? Then, for example, in that work that I showed, we have some annotations that we can put. Okay, this annotation, it's only valid if the class has this other annotation. So then you can just mark them and then you get the validation for free. So I believe that if some more established API like this existed, then the frameworks would do a better job on doing this.
But what I also mean is a bug in your own application code, just standard bug, you forgot to make a check, null pointer accepts, whatever. Is it harder to find such a bug if you use a framework because the debugging is so much harder to do? Because you have to work with breakpoints. You cannot just step through, oh yeah, there is my mistake. You have to really...
Yeah, the point is like, as you said, it's hard. The hard is the debugging, right? So sometimes even it's hard to have a bug. It's more rare to have a bug, but the debugging is hard. Like for example, when you get a bit expert on the framework, you already can figure things out. This might be because of this and that. Of course, you can have testing, but testing things with the annotation, it's a bit like not really testing behavior, testing if the framework understands your class correctly. So sometimes are also not really easy or worthy to do. So yeah, that's an issue. But in the end, like it's an issue when you have any solution that is declarative and based on configurations, right? So what changes in the annotation is together with the code.
Yeah, beautiful presentation you did there. I have a few questions about the questionnaire you did, specifically about the demographic of it. Like, can you give a little more insight on it? Like,
I don't really remember, but I think like the one on readability.
Yeah, I mean exactly.
Okay, this one we got I think 300 more than 300 people, which is for this kind of studies a lot. Andre, that is a researcher, you know that do a survey, get 300 answers is hard because it's voluntary and people need to spend time. But we kind of, I ask a lot of favors, like, oh, please do it, ask your colleagues to do it, blah, blah, blah. And then I think we got a good mix of both experience and junior developers. So we get a good distribution on this. And I get some impression also that some, I don't know, maybe the new developers, they are more used to annotation. So, okay, they were born with the annotation in the language. Maybe the oldest ones will complain on it. We have haters and lovers on all types of experience levels. We ask for experience. We ask for familiarity with annotations. For example, we ask how many frameworks with annotation you already use. So we also have this difference, but nothing really affect the medium result.
Okay. And another question.
In the paper, we get this more in detail. So
yeah, I'm probably going to read that later, actually.
Good.
And another question about the questions themselves. Like, do you think that because you provided, from my understanding, very small snippets of code, that could affect the result? Like, if you provided more complex snippets, do you think that people would see more of a difference in the code reliability or not?